All right, so here's the street scooter after the build. This is made to be affordable, practical, and longevity. Nothing crazy, nothing fast. I think it meets 20 miles an hour, but it probably could go like 30, 35 miles range. This is a 800 watt hub motor here, so nothing crazy. Controllers built underneath here, batteries under here right in the center. It's a 20 amp hour battery with 48 volts. All the wires come through the neck here, come to the throttle. It has a display. Big hydraulic front brake. The reason of this naked look was more cosmetics to make it look kind of unique where there's nothing here. Again, that was for cosmetic looks. Let's see what happens. You can see the sound of it here. It's real quiet. Real simple. This display here will tell you everything. It'll tell you the mileage that you could get, the miles you went, and your volts and your speed. Let's take a look at it if we spin it around here. So you can see there's a huge caliber here, way too big than you need. And the cool thing, if you need to fit it into your trunk or you want to go somewhere and make this a little bit more simpler, no tools needed. And it comes down like that. Very simple. So it's easy to put into your car or truck, and then you put it back with no tools needed. All right, so after riding this a few times, there's always some improvements to be made. So I'm gonna make some revisions. I'm gonna do a revision build. I'm gonna basically take this front end off and make it a little bit more, not as cosmetic, make it more, just more stronger and lighter. And the seat position where you're standing in this particular arrangement with the original, your feet wanted to be in the back here. I want your feet to be more in the center. So I'm gonna make this next arrangement so the handlebars come a little bit more forward and a little taller. Other than that, I might switch a controller out to a better one, and we'll go from there. If you wanna see that build video, that'll be in the top right corner. If not, if you just wanna see the revision one, let's take a look at it right now.
So here's a 3D model I made to scale. Here's the first version that you just seen with the 6 foot person. And here is the revision 2 that I do later to make some improvements. All right, so on this build, what we're trying to do is make a practical street scooter for someone, just say going to school, grocery store, nothing to go fast, something affordable, and it has long range and lightweight. So what we got here is a 1,000 watt hub motor built into a 13-inch tire. Same with the front, just a freewheel tire. A inexpensive battery, 48 volt, so like a 54.6 volt max. Nothing that produces more than say 35 amps continuous, because this is just a basic scooter. The controller, which is programmable with a nice, out of all my builds, this is the best throttle so far I found. Look at this thing. This thing is awesome. So we'll see how good this thing works in the build. And then everything's made out of aluminum here. So check this out. We got 1/4 inch, 3-inch plates. We got 1x2 square, and we got 3 1/4 by 1/4, and then plate that I got cut custom, and a battery plate. We're gonna make all this a lightweight scooter for practical, how do we say it? A lightweight scooter for practicality. Is that a word? Basically, it's a practical scooter. Affordable, lightweight, let's just go far. No worries. That's what we're doing here. welding the aluminum. Getting the frame aligned and all the welds perfectly straight. All right, so cutting aerodynamics of the frame, making it shaped like a rocket. There's my missile I made. Brilliant. putting on the watertight connectors and the controller. Getting ready to cut those little ends off here to make it more aerodynamic. Getting the front wheel to spin correctly and aligned with the frame.
Sit on the camera. Sit on the camera. Thank you. Watch.
Here I am making the front fork system. Getting it a little bit shaved off of the tube so the bearing can fit just right. Look at how this fits like a glove. This reinforces the main fork system so it would not have any problems. Now it's cut purposely on one side so one wire could fit on the other side. That's how this was designed. So the clear coat is 100% of the most important part to make something last. And this is an automotive clear coat, a 2-stage. You can't get in California. You have to get it shipped here from a third party, like my parents. Boy, does it make a difference when you get a good clear coat. Putting in the charging port for the battery. Drilling the holes to be able to tap at M5 threads for the battery maintenance plate. Putting on the vinyl cover to make it look pretty. Fitting in the battery and wiring all the components. Mounting the hub motor. Hiding the wires. Cleaning the surface with acetone and then putting in grip tape like a skateboard. All right, so here's revision 2. Here's some of the updates I fixed. Like I was telling you, I fixed the front end. The first front end was just too wobbly, having a 1 fork. So I went back and made a 2 fork system and actually made it even lighter and stronger. So I also pushed it forward like I was explaining, so your feet position is more in the center of the scooter instead of the back. It just felt better. And I made it so this is not retractable down. It was just too much work with aluminum and it causes bending issues, so it's just one piece now. But I went ahead and made mounted a smaller brake caliper. The other one was just too big and bulky. I don't have the right length hydraulic wire yet, so it is pretty huge, but that's the only one I have right now, and I don't have this all wired up correctly as far as wire management. But here we go. Here's the charging port up close. Back in. the display. Yeah, and you don't need to ride like a skateboard. Just straight feet up.
Yeah, I can tell like the turning, the tires are really wide. It's hard to
Let's look at the next video. This is something very unique. This is kind of like a tank slash robot slash monster chair. So this is made out of all of aluminum, huge hub motor, and then it'll be a free wheel back here that will just spin on a pivot. There's no steering wheel, obviously, so this is controlled as like an independent steering. One tire will move faster than the other, and it could turn like a tank where one tire will turn reverse, one tire will turn forward, and you'll be able to spin. How that's all done is with this Arduino chip here. These are for robots and different things. You could plug these into the computer and program code to them to, for instance, work a joystick like I have here to then signal to the controllers to do different things to our motors. You can do it, it's endless. It's all up in your imagination. So this will have a forward, a backward, and a twist. So you'll be able to turn like a tank, and it'll have a feature of a button to switch to different modes. It'll be a huge seat that goes here, like that seat. I'll show you a picture. And batteries and everything going here. And we're in the test phases, or I'm in the test phases right now. And the hardest part I just tacked weld this just to make sure it's gonna work first, because aluminum is very expensive right now. That was easy. This has been a nightmare to get this configured, so I think I'm on the right track. So this might actually work pretty good. And then in the future, I want to make an off-road one with a suspension, and be pretty cool.